Hello there, I'm Daniel and I'm a vacation work student at Optimum Solutions. I'm going to put you in a scenario. You've just won a one-way ticket to a country that you've never visited before. You soon realize after spending a bit of time there that the host society is a bit different to the one you're normally used to. The language, the culture, the social norms, the everyday behaviors and gestures are all a bit different. This isn't all too bad because you know that you'll just be able to learn and adapt by observing the environment around you. You'll soon start to realize what is wrong, what is right, and use this knowledge to make informed decisions. This is a simple scenario, but it's very similar to what reinforcement learning is for machines, and in this video, you'll see just how useful it is as a tool in Industry 4.0. A lot of people might not be familiar with the concept of reinforcement learning, and that's okay, because it has only become more popular recently due to new deep learning research. Basically, machine learning can be broken up into three subcategories: supervised, unsupervised, and reinforcement learning. For supervised learning, the algorithm that you're training receives a fully labeled dataset. This basically means that the algorithm receives data with attached answers and works through them to predict the answers for a future set of problems that have no answers. In unsupervised learning, a deep learning model is given a set of data without any explicit instructions of what to do. The neural network will then attempt to find a structure to the data by extracting similar features or anomalies. Reinforcement learning, also known as RL, is a goal-driven computational approach where a computer learns to perform a task by interacting with an unknown dynamic environment. All three of these machine learning categories can be incorporated with the use of deep learning. Now, deep learning is a machine learning technique that learns features and tasks directly from data. These types of datasets can be in the form of images, text, or sound. The term deep refers to the number of hidden layers within the neural network. Most complex problems are often solved using the use of deep learning. Okay, let's pause for a second. You might be hearing all of these words and you might be thinking to yourself about the possible pending robot apocalypse, especially after hearing the phrase neural network. But in reality, this won't happen. In fact, it's actually a massive leap for Industry 4.0, as it can be used to optimize most existing systems by the use of digitalization. An example is software simulations, which can provide the opportunity to train a model and validate it before deployment. This is very beneficial for environments where safety should be regarded as a priority, like many process, mining, and manufacturing environments. With the release of MATLAB 2019A, the new Reinforcement Learning Toolbox is definitely a tool to consider when thinking about safety, productivity, and optimization of your plant. The next video will explain just how useful this toolbox actually is. But for now, let's talk a bit more about what reinforcement learning is and why it is so special. In reinforcement learning, an agent interacts in a specified environment using the judgment from a decision-making network known as a policy network. In traditional control theory, this is very similar to how a plant reacts to signals received from a controller. However, instead of manually adjusting the parameters of the controller to suit the dynamic environment, like a PID controller, an RL implemented controller can be used to tweak those parameters automatically. By doing this, you can achieve greater efficiency with cutting-edge technologies. As the agent interacts with the environment, it will receive rewards based on its actions. So you can see it as a type of reward-based learning. The agent is rewarded if it performs the correct action, while the opposite is true for when it performs an incorrect action or something that deviates from the desired output. The agent will learn via a series of trial and error episodes of which actions will produce the most optimal outcome, or in the machine's mind, which actions will produce the most rewards. These episodes are collectively known as the training phase. As the agent undergoes training, it becomes more experienced and will choose actions that will produce more rewards. These training processes can take days to complete, depending on the complexity of your system. So, in short, the agent can optimize its performance by slowly filtering out the actions that will deduct rewards. This type of learning method is used in robotics, control systems, gaming, predictive maintenance, and vehicle automation, such as self-driving cars and lane assist systems. It can be incorporated in many other fields, such as control systems that govern the activity of larger systems in factories, mines, and process plants. Reinforcement learning can be used to train a robot to walk on a designated path as shown. For this example, a method of reward shaping was used to optimally adjust the rewards function to help the robot train faster. It can also be used to stabilize a cart pole system, which is a common control systems problem. And yes, it is even implemented in gaming environments, such as Minecraft and Go. The Reinforcement Learning Toolbox is introduced in the new release of MATLAB 2019A, and it makes the implementation of the agents in an existing system relatively simple and neat. Here you can see that the reinforcement learning implementation looks very similar to the traditional control problem. The plant can be related to the environment, the output of the plant to the observations, and the agent is the combined workings of the controller and an algorithm. The RL algorithm simply updates the policy network or the controller after each training episode to help the agent perform a better action in the future. Hopefully this video has helped you grasp a better understanding of what reinforcement learning is and how it can be beneficial for your business and in the fast-developing era of Industry 4.0. The next video will introduce the actual simulation environment within MATLAB and Simulink by walking through an existing model example.